Welcome to the 14th lecture on spur and helical gear cutting, and we were discussing one numerical problem on gear shaping, spur gear shaping on the Fellows gear shaper, and let us continue with the last part of the problem. Okay. So, let us quickly go to the problem statement. Yeah, this is it. We have up till now finished up till this point, that is the second question, and we were discussing, just to pick up the threads, we were discussing the cutting of a spur gear on the Fellows gear shaper. The Fellows gear shaper works on the principle of generation. Okay. Okay. So, last question that we have left is, how do I set the value of UI? Now, if you recall the discussion in the last lecture, UI is situated here and UI is decided by the number of teeth that we are going to cut. What is the number of teeth that we are going to cut? We are cutting a gear of 40 teeth. And what is the basic idea? The idea is that UI should be set to such a value that the rotations that I am providing to the cutter and the workpiece should be exactly equal to the inverse ratio of the numbers of teeth on the cutter and the workpiece, so that they will be rotating as if they are rolling with 20 and 40 teeth respectively. So, the cutter is having 20 teeth and the cutter should be having a speed, rotational speed exactly twice of that of the workpiece, because 20 teeth and 40 teeth, the inverse ratio is defining a speed ratio of that way, of that much. Okay. So, how do we solve it? What we do here is that we can start moving from the cutter, move backwards right through these machine elements, come to the main line, and then you simply go forward and come to the workpiece, and whatever rotations per minute you come up with, equate it to the value of the rotations that is required. So, let us start it right away. Suppose the cutter is rotating once. If the cutter rotates once, how many times do you think the worm gear is rotating here? This one, the worm gear must be rotating once also, because they are sharing RPM. If the worm gear is rotating once, how many times do you think the worm will rotate? Surely the worm is going to rotate at a much higher rate, given by this ratio 1 by 50. So, if a worm rotates 50 times, it makes the worm gear rotate once. Sorry. So, here if the worm gear is rotating once, we come up with the idea that the worm is rotating 50 times. So, when we move backwards through machine elements, then we take their reverse speed ratios. Generally, when we are moving forward from worm to worm gear, we get 1 by 50 here, and here we will get 50 by 1 when we are moving backwards. So, let us start writing down the values. First of all, cutter rotation, 1. We put the cutter rotation to be 1, and then we multiply it by, so it is the same as the worm rotation, and then we multiply it by 50 by 1, okay, the reverse ratio, to get the worm rotation. Fine. After that, through the bevel gear pair, we come to the main line. It is just like a car backing off from a by lane onto the main road. So, you are going reverse, and after reversing you come to the main road, that means the national highway, and then you are moving forwards, and when we are moving forwards, all the ratios will again be taken as the straight ratios, not reverse. So, now we move through the two bevel gear pairs, come down and enter UI. So, that at the output of UI this will be the rotation. So, we write output of UI, okay, output of the gearbox of the index gearbox. After this we have a bevel a worm and worm gear pair, and it is given K3 equal to 1 and Z3 equal to 60. So, we have 1 by 60. Now, the ratios are not in reverse anymore, because we are moving forward through the machine elements worm to worm gear we are moving. So, fine. So, this must be equal to the workpiece rotation, and let us equate it to the workpiece rotations that we would have for one rotation of the cutter. For one rotation of the cutter, the workpiece rotates only half a times, and we put it to be half here. So, that is it. We get the workpiece rotation here, workpiece rotation. Now, let us solve for UI. UI must be equal to half into 60 divided by 50 equal to 3 by 5. The value of UI comes out to be 3 by 5. So, we have solved for UV, we have solved for US, and we have solved for UI. And this is the way, in a very simple process, we can solve for gearbox ratios corresponding to particular cutting conditions, particular number of teeth, and particular feed conditions, okay, speed, feed, number of teeth. Given these things, we can easily find out the numerical values of the gear ratio, gearbox ratios that should exist. Okay. So, if time permits, we will also take up other numerical problems of this type, so that you will be quite conversant of how to set up gear, fellows gear shapers in order to make them work properly. Okay. Next, let us now take up a number of multiple choice questions which will help us in learning more about gear shaping. To start with, in gear shaping, feed gearbox, okay, remember the feed gearbox, controls in brackets I have put the function of the feed gearbox. So, in case some person cannot recall it exactly in the exam hall, in gear shaping, feed gearbox which controls circumferential movement per stroke, that ratio, I mean feed gearbox ratio, depends on feed only, module of the cutter only, number of teeth of the cutter, none of these. Okay. Now, let us take the options one by one. Feed gearbox depends on the feed only. Now, first of all, you will say feed gearbox, what was the expression? So, let us quickly recall the expression. It was something like this: US was equal to 50 into pi into m into ZC. Okay. Sorry, I made a mistake. I will just remove this from consideration. Yeah, this is it. US into 1 by 50 into pi mzc equal to 0.25. Okay. Now, let us generalize it. US equal to, we will put this as a constant. Okay. We are not we are generalizing it, so it comes as a constant, and let us take it already to that side. So, it is equal to k 1 multiplied by pi, pi is also a constant. So, let us say that k 1 gulps down pi and gulps down this, collectively we are writing k 1. So, what else is there? M goes down, M goes down, number of cutter teeth that goes down, and this we generalize as the feed. Okay. We can call it F or we can call it S. Let us call it S. So, we find that the feed gearbox ultimately depends upon some machine constants, and it depends upon the feed specified, okay, feed specified, the module and the number of teeth on the cutter. It depends upon these things. And now, let us come back to the problem. So, first option, feed only, that is not correct, because apart from feed we have just now noticed it depends upon the module and it depends upon the number of teeth on the cutter. So, this is definitely not correct. Feed only is definitely not correct. Module of the cutter only, definitely not, because it depends upon the feed specified and also the number of teeth on the cutter. Number of teeth, the third option, number of teeth of the cutter. Now, the moment you notice that only is not mentioned, you have to accept this as correct. Yes, it definitely depends on the number of teeth of the cutter. You might say, but it also depends upon other things. This is not fully correct. No, it is fully correct, because it is simply stating that it depends upon number of teeth. Whether it depends upon something else is not our botheration. This is correct. Yes, it does depend upon the number of teeth. So, this one is correct, and therefore, definitely naturally none of these is not correct. So, the correct option here is C. Now, here when you deal with multiple choice questions of this type, the moment you come across only, you have to become very alert, because you might find that yes, it depends upon the feed which we have stated 0.25 in this particular numerical problem, and therefore, it depends. But if you come across this only, be very alert. Does it only depend upon the feed? You have to ask yourselves. Okay. So, whenever you have only, be cautious. Next problem. What is this problem? This problem, after learning so much and discussing so much about Fellows Gear Shaper, it should be extremely simple for you. First of all, we have stated that UI controls the number of teeth to be cut, US controls feed in millimeters per stroke, UV controls the cutting speed in meters per minute. I have just jumbled it up. Okay. You already know this thing very well. So, what is the question? The question is, in the schematic of a gear shaper, the gearboxes UV, UI and US, mind you, UI has been placed in the middle, should have the following locations respectively. So, first option is that 1 should be UV, 2 should be UI and 3 should be US. Second option, that 2 should be just a moment, yeah, UV should be this one 2, 3 should be UI and 2 should be and 1 should be US. C is 1 should be UV, 3 should be UI and 2 should be US. Fourth one, 3 should be UV, 1 should be UI, and 2 should be US, and E is none of the others. So, we know after so much discussion that without any exception, this one should be UV, this one should be UI, and this one should be this one should be US. I am extremely sorry. This one should be US, and this one should be UI, and hence C, option C is correct in this case. Option C. Okay. For producing a straight tooth spur gear, Fellow's gear shaper requires that only workpiece rotate, only cutter rotate, both cutter and workpiece rotate, none of the others. So, which one is correct? Only the workpiece rotate, but the basic condition which has to be satisfied in case of gear shaping is that both the workpiece and the cutter should rotate as if they are rolling against each other as finished gears. So, only workpiece rotate is not possible. In the same manner, only cutter rotate is not possible. Both cutter and workpiece rotate is correct. None of the others is therefore not applicable. So, hence here the correct answer is C, both cutter and workpiece rotate. In gear shaping, reciprocation of the cutter is imparted by cam follower, rack and pinion, screw nut, none of these. So, in order to find out this answer, I will just introduce what they exactly mean. Some of them you are already conversant with, and some of them. What is cam follower? Cam follower can be something very simple of this type. Suppose this is what we call as the disc cam, and this is its center of rotation. So, you can very well understand that it is having a non-circular profile, a lobed structure, and therefore, it is going to push this body outwards if it is having a guide way. If it is passing through guides, it is going to push it outwards, and if it is spring loaded, if there is a compression spring, this is going to come back when this rotates and say takes up some position of this type. Like that. So, if this rotates continuously, this is going to execute reciprocation. Question is, do we have that kind of a mechanism for imparting the reciprocating action? No. Why not? Because in this case, generally the problem is the stroke is not quite adjustable. If you want to change the stroke length, it is difficult. So, generally we go for crank connecting rod mechanism, where it is easy to change that. Now, why do we need to change the stroke in case of gears? That is because the width of gear which is being cut, it might differ from case to case, or you might be cutting a stack of gears like this. a number of gears in a stack can be cut by a single stroke of the cutter. Okay. Up, down, and gear number 1, 2, 3, 4 together can be cut. So, this stroke length is very frequently it has to be changed. So, cam and follower is out, but interestingly cam and follower is used in this particular mechanism, I mean in this particular machine, for the small amount of relieving motion which is required when the cutter goes up. The cutter goes down, the cutter relieves itself and again moves up. This small motion can be realized by the help of a cam follower device. Okay. So, coming back to the question, we have cam follower, no. Rack and pinion. Rack and pinion is able to produce reciprocation, but the problem is that what do you call it, there are other many much more easier methods by which we can have reciprocation, because if you use rack and pinion, you have to have yet another device by the help of which reciprocation will be obtained. Rack and pinion can only change rotation to straight line movement, but it cannot bring about reciprocation. Okay. So, that is why it is not a good choice. Screw nut mechanism. Screw nut mechanism is also not used, and therefore, none of these is the correct answer. None of these. Okay. You might say that why is screw nut not used? Screw nut mechanism is not used, you might say, because the screw will have to rotate very fast inside the nut, and lot of sliding wear will take place unnecessarily. There are so many other easier options to obtain reciprocatory motion. And also screw and nut won't be able to give you the reciprocation. You have to have another mechanism, or you have to have another type of controls which will give you reciprocation. Screw and nut can only bring about rotation to linear motion, that is not reciprocation. Okay. In a gear shaping machine, it is not possible to cut a helical gear, a straight spur gear, this should be an internal gear, and none of the others. We can cut, so first of all, helical gear. Helical gears can be cut on shaping machines, though not as simply or elegantly as on the hobbing machine. The hobbing machine can cut helical gears by a very simple procedure. Okay. In gear shaping machines, either we have to have a mechanical guideway which will make the cutter move in a helical manner, or we have to have some sort of computer control. So, it is possible to cut a helical gear. Next option, a straight spur gear. On in a gear shaping machine, straight spur gear is the obvious thing which can be cut. So, this is not correct. An internal gear can be cut. Okay? Internal gear can be cut. So, none of the others is the correct answer. In a gear shaper, the machine is set up for cutting 40 teeth on a blank for straight spur gear. If now the customer changes the order for cutting 80 teeth, the options are, so I have set up the machine for cutting 40 teeth, and suddenly the customer comes and says that no, I want 80 teeth. So, the options are, the speed gearbox ratio needs to be changed, the feed gearbox needs to be changed, the index gearbox needs to be changed, and none of the others. The speed gearbox needs to be changed. Why? We are not changing the speed. If I am cutting a 80 teeth gear instead of 40 teeth gear, why do I really need to change the speed? No, not at all. So, the first option is not correct. Second one, the feed gearbox needs to be changed. Am I changing the feed? Do I need to change the feed? Not really. Feed is going to define the surface finish, and the customer has not stated that he wants to change the surface finish. No, not at all. So, we still have no need to change the feed gearbox. Last of all, the third option, the index gearbox needs to be changed. This is correct. Yes, the index gearbox needs to be changed so that we can accommodate the 80 teeth gear and have the proper RPM ratio between the cutter and the workpiece, so that the 80 teeth gear is cut correctly with correct geometry. So, option C is correct, and therefore, naturally none of the others is not applicable. So, the index gearbox needs to be changed. A gear shaping machine has been set up for cutting a 44 teeth spur gear. However, the 24 teeth cutter breaks, it's damaged, it's gone, and has to be replaced by a 30 teeth cutter of same module. In that case, the feed gearbox and the speed gearbox need to be changed. The speed gearbox and the index gearbox need to be changed. Third option, the index gearbox and the feed gearbox need to be changed, none of the others. So, let us see, if my cutter number of teeth is changing, what are the things that need to be changed? First of all, once the machine has been set for 44 teeth to be cut on a spur gear, then UI must have been set with respect to the ratio of the numbers of teeth on the cutter and the workpiece. Therefore, UI will definitely get changed. Second, if the number of teeth of the cutter is changed, we have previously learned that US will change. Why? Because US, as we learned, that US is equal to a constant multiplied by module and also the number of teeth on the cutter and also the feed. It depends upon the feed, specified feed. It depends upon the module of the cutter, and also it depends upon the number of teeth on the cutter. Therefore, as the number of teeth is changing, therefore, we will definitely have a change in US. So, the answer should be the index gearbox and the feed gearbox need to be changed. So, the third option is correct. The third option is correct. Let us see, do we have any other options? Okay, we can take another one. If the cam for radial in feed has a continuous Archimedean spiral with the cam rise equal to total depth, the result would be the teeth on the gear blank would be perfectly cut. The teeth on the gear blank would all be incompletely cut. Some of the teeth on the gear blank would be completely cut. Now, what is that? The second option and the third option, are they different? Would all be would all be incompletely cut, and third option is quite tricky. So, let us take them one by one. The teeth on the gear blank would be perfectly cut. No, absolutely wrong, because if you are having an Archimedean spiral continuously rising from the beginning right up to the end, that means the depth is continuously increasing and there is no teeth which is going to have the correct depth, because the correct depth will only be reached at the very end where total depth is achieved. So, teeth in the gear blank would not be perfectly cut. Second option, the teeth on the gear blank would all be incompletely cut. This seems to be correct. Yes, would all be incompletely cut. Maybe only the last one, okay, that also for an instant only it will be having the correct depth. Some of the teeth on the gear blank would be completely cut. What does this mean? It means some of them would be completely cut. No. If you are having continuous Archimedes spiral, basically the difference is that you are nullifying the idle period or the dwell period of the cam, during which it distributes the complete cut. That means the total depth for all the teeth. For all the teeth, the cam remains at a particular position. There is no further radial infeed. Total depth has been achieved, and it simply goes on cutting, so that each and every teeth have correct depth. Therefore, option B is correct, and naturally none of the others is not applicable. So, with this we come to the end of the 14th lecture. We will take up other subjects in the subsequent lectures. Thank you very much.